All right, Bob the Circle Guy. Let's do your question. Although if you're the Circle Guy, you should be able to do this. But what are you gonna do here? First off, let's turn off this question because we already wrote down the question. So, I mean, first off, of course, you're gonna combine the signs, right? We want to kind of write this as a quadratic with sine instead of x, so like sine squared. And we know that because we have like a sine. And the idea is, well, first off, we have to know some formulas. So we have to know the double angle formula for cosine specifically. You got to know that cosine of 2 theta is, there's a song for it. Well, the sine one is, it goes sine, sine, cosine, cosine, sine, cosine, 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 sine, sine. And so we want the second part in this case. We want the one that goes cosine, 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 sine, sine. And then there's some special stuff. You got to remember that that's minus. And then the song formula is mainly for the idea when you're adding two angles. So in this case, you're just thinking about 2 theta is theta plus theta. So we get this because the angles are just the same. And then we write that a little better and say that that's cosine squared of theta minus sine squared of theta. And now that's just a formula that you should really probably just have memorized. And this is the one that there's actually a couple other versions of this formula. And that, again, from the circles, so you should be the expert, is that we know that sine squared plus cosine squared equals 1. So we can get rid of the cosine because subtract sine squared from both sides. Cosine squared is 1 minus sine squared. So we'll just do that replacement. We'll say that what we really have then is 1 minus sine squared of theta minus sine squared of theta, which is 1 minus 2 sine squared of theta. And so that's the substitution that we're going to do. So let's go all the way back up to the top. So we're going to replace cosine of 2 theta with 1 minus 2 sine squared of theta. So then we have 4, 1 minus 2 sine squared of theta, plus, and then remember we subtracted the 3 sine to the other side, so plus 7 sine of theta, and then also subtract the 4, minus 4, equals 0. And so you can see how this is going to start becoming a quadratic. We might want to change the sign on the sine squared, just because it's usually nicer when that's positive. But so first we're going to distribute the 4. Ooh, and the 4s are going to cancel. That's actually going to be extremely, extremely helpful. So we're not actually going to have trouble factoring. Anyway, so 4, and then minus 8 sine squared of theta, plus 7 sine of theta, minus 4 equals 0. So beautiful stuff. The 4s go away. So now we can just factor a sine theta out of everything and have a decently easy job factoring. So then we factor a sine theta out of everything. This is negative 8 sine of theta plus 7 equals 0. So I guess we're going to have to bust out the calculator a little bit. Because now we have the zero product property. So either two things multiplied together to be 0. So one of them is 0. Either sine of theta equals 0 or negative 8 sine of theta plus 7 equals 0. And then we just got to solve both of those. So when does sine of theta equal 0? Specifically between 0 and 360. I don't know why we're using degrees. But between 0 and 360, it's going to be 0 at 0 and 180 degrees. And then over here, we got to solve for this. So we'll subtract 7, divide by negative 8. So sine of theta equals 7/8. I mean, you just got to put that in the calculator, right? Or you go the inverse sine of 7/8. That's not something special, right? Numworks will tell us if it is. No, if that was something special, they would have written it perfectly. So yeah, you just have to use the calculator for that. So we get that theta is... Oh, I'm in radians though. Should I convert that? Yeah, let's just convert that. So right now we're in radians. We need to cancel out radians. So we need to multiply that by 180. and divide it by pi. And we get 61 degrees. Does that seem legit? I mean, that's really close to 60 degrees, and we know that the sine of 60 degrees is root 3 over 2. What's root 3 divided by 2? 0.866? Is that really close to 7 over 8? What's 7 over 8? 0.875. Okay, yeah, so that makes sense. But that's not it, right? Because you'll always expect two of them. So you got to think, when is sine positive? First quadrant and second quadrant. So then you have to find the reference angle by doing 180 minus 61 degrees. So that should get you 119. And those should be your four answers. Those should be your four answers. But what's weird about, like, or weird to me at least, but this just speaks to the whole education system. I want to check the answer too. That if we have to bust out the calculator to solve this anyway, why not just type the entire equation into the calculator? It won't be able to solve it perfectly for us right away, but it'll even ask us where we want to look for answers. Sine of x. I guess I should have just written 7 there in the first place. But equals 3 sine of x plus 4. Enter. Solve, please. Let's look between 0 and 360. Because we're in radians, though. Hang on. Let's change our settings real quick. Radians, degrees, home. Boom, 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 boom. Solve between 0 and 360. Boom. We got our 5 answers because they included 360. And it's exactly what we said. We got 118.95. That's our 119. We got 61 degrees. We got 0 and 180. So I suppose you could just, like, you don't need a solver calculator to be able to get them. But yeah, that's how you would do that. You got to know your double angle formulas.